Hey everyone, it's Mr. Canfield. Today we're doing 1-1 notes, measuring segments and angles. So this is the beginning of geometry. So we're going to start with explore and reason. A teacher labels 2 points on the number line. So you can see point A, it's at -3, and point B is at 5. So what are some methods for finding the distance between points A and B? You can use the pen tool to explore different options on the number line. And then B, construct arguments. Which method of finding the distance is the best? Explain. All right, so have you thought about it yet? If you haven't thought about it, pause, think about it, and come up with at least 2 ways. So here's one way. If I want to find out how far it is from A to B, I can go 1, 2, 3, 4, 5, 6, 7, 8. So from A to B is 8. That is one valid way to do this. Here's another one. I could go, let's see, from here to 0 is 3, and then from here to B is 5, right? So if I count how far away they are from 0 and put them together, 3 plus 5 is 8. That's another way to do it. Another way to do it is to take the final, the ending, and subtract the beginning. We can call that the initial. So I could do 5 minus -3. And what happens when we subtract a negative? We're adding a positive, right? Subtraction is just the same as changing the sign of the subtraction and the thing after it. So 5 plus 3 is 8. So one way you get 8, another way you get 8, a third way you get 8, and I'm curious if you got a different way. And if you got a different way, I'd love to hear about it. Regardless though, you should be writing something down in here. Don't write that. Write actual words. Which one's the best? And I'm not going to lie, I don't think any one of those methods is better than the other. They're all useful in different circumstances. Sometimes counting really is the most convenient way. Sometimes finding what we would call the absolute value of each and adding them up is the most useful way. It really depends on the situation. Of course, this way is oftentimes the fastest, but when we're constructing arguments, it doesn't mean that we're necessarily right. We're saying, this is why I'm thinking this way. So which way is your favorite and why? Which one do you like the best? Why? So I wonder what happens if I click this. Oh, what if I call this 1-1 EX, or no, this was explore and reason. Oh, it's having me insert a picture. Wah, wah. So it looks like I can't save this. You know, if I was doing work like this and I was trying to submit it to my teacher, I would like screenshot it. All right, number 2, or well, section 2, or part 2. Example 1, find segment lengths and try it. So we get into notation here. See how it says CD with a line over it? This means line segment CD. So how do we find the length of line segment CD? Let's see what they tell us to do. The length of a segment is a positive real number. Oh yeah, right. Can length be negative? No. That'd be silly, right? Oh, that's -2 feet long. No, you would just say 2 feet long. So you can use the number line to find the length. So they suggest counting. Wow. All right. So they're communicating precisely with us here. So let's see what it says. To find the length of a segment, count the units of length between the endpoints. There are 3 units between C and D, so CD equals 3. Notice how there's the line over it, and then this time it doesn't have the line over it. The notation, CD represents the length of line segment CD. Therefore, the length of line segment CD is 3. So notice that when we put the line over it, we're saying, hey, the line segment CD. And when we don't put the length, we would, in this case, we would just be talking about the number 3. It's a minor difference, but it's worth noting. It's worth taking a note of. Which reminds me, if you are not taking notes on paper somehow, or taking notes in a way that you can save them for later, I think you're making a mistake. Right here, this is a super important idea. And so it might benefit you to have a piece of paper and to be like, you know, if this is A, B, C, D, just kind of making a little mock-up version of this, you could say that CD with the line over it, this is, and you know, I'm going to type because I'm on my computer, the actual line segment. And then CD without the line. The line isn't over it, so it's just the number 3. And I would want to make sure I go like this is 3, put a little indicator. So like there, we've shown ourselves like, great, now I remember what that is. Let's go on to example 2. Try it. Refer to the figure shown. How can you find the length of AC? And so it says, how can you find the length of AC? So it's not just asking us to go 1, 2, 3, 4 and get 4. I think it's actually asking us count. Yeah, okay. And so we would use AC equals 4. So you might be already starting to get a little bit worried about this class. Oh no, he's going to make me write things in really specific ways, and if I don't, I'm going to fail. Don't worry about it. We're going to do a lot of this together, but we do want to try to write things correctly. So as we're going, you know, I'm going to be there for you to hopefully help you write things the correct way. All right, let's move on to part 3. Let's just hang out here forever. Come on, come on. There we go. Points F, G, and H are collinear. Wait, what? Collinear. You might not even have realized that that's the word collinear. Let's break that down really quick. It's a super fancy sounding word at the beginning. Co. What does co mean? Same. Linear. What does linear mean? Linear means line. This literally means same line. 2 points are collinear if you've got a line and they're both on that line. So like we would say A and B right here are collinear, but C is not collinear. That's all that means. So if GH equals 16, what is FH? Huh. I wish I had that pen tool so I could write on this. I thought it was going to be like on everything. I was so excited. All right, so let's talk about this, right? So I guess I have to use the scroll bar down here. Okay. If GH equals 16, what is FH? Well, this is, okay. I know that this is 16. So one way for us to think about this is that this is 16 and this is something else, and we don't know what it is. But 16 and 2x plus 2 are talking about the same line segment. So what I could do is, oh, well that means that 16 and 2x plus 2 have to be the same thing. And you might not want to write it like that. You might want to write 2x plus 2 equals 16. So you can do that either way, and then we can just solve it. And I'm going to say, go ahead and solve it. if you don't know how to solve it, I'm going to solve it right now. So I'll solve this one on the right. They're literally the same thing. They work the same way. I want to get x by itself. So to get x by itself, we do PEMDAS backwards. So let me write PEMDAS. And the way we do PEMDAS backwards is we focus on addition and subtraction first. So I see I got plus 2. I want to undo plus 2 by subtracting 2 from both sides. And you can put the lines in if they're helpful. So 16 minus 2 is 14. And then we bring the 2x down. So 2x equals 14. And then we do any multiplication or division next to get the x alone. And so this is 2 times x, so we divide both sides by 2. 14 divided by 2 is 7. So what is 7? Oh, 7 is x. Okay, so I know x is 7. And let's just double check. 2x plus 2. If I plug in 7 for x, 2 times 7 plus 2. Well, 2 times 7 is 14 plus 2. 14 plus 2 is 16. Yep, so that makes sense here. So then 3x minus 1. Oh, wait, it's asking me for FH. It's not asking me for this. It's asking me for FH. It's asking me for the whole thing here. But here's the good thing. I need to know this bit here. If I know this bit here and I know this is 16, don't we know the whole thing? So let's see, this bit here, if I plug in 7, well, that's 3 times 7. And then we're going to take away 1, right? So 3 times 7 is 21. Minus 1 is 20. And you might be like, Canfield, this doesn't make any sense. This little bit here is 20. This long bit here is 16. That makes no sense. So sometimes our pictures aren't drawn to scale. They're not drawn to represent exactly what's happening. And we need to find the numbers as they work, not the numbers as they should be. So like if this was 16, then this should be like 3 or 4, I would think. But instead, this is 20. So if this is 20, this is 16. What's the whole way from F to H? It's 20 plus 16. Oh, it's 36. All right. Let's see what they do. Collinear points lie on the same line. We figured that out. Step 1. Use the expression for GH to find X. So GH equals 16. We know that 2x plus 2 is equal to 16, right? So we said instead of calling it GH, we can call it 2x plus 2. They subtract the 2 from both sides, divide by 2, they got 7. Then we have this thing called the segment addition postulate. So we're leaving that out of our notes here, but the big idea, it's kind of common sense, right? If you've got a whole segment, the 2 pieces, or however many pieces there are that make it up, if you add all those pieces together, you have the whole thing. So it says FH, so going from FH is equal to FG plus GH. So 5x plus 1. Oh, interesting. They did this differently than I did it. So what they did was they took this and they said, hey, these 2 things added together is the whole thing. So they said, well, I know that 3x minus 1 plus 2x plus 2, that's equal to the whole thing. And they combined like terms. So they took their 3x and their 2x and combined them and got 5x. And then they took their minus 1 and their plus 2, combined those and got plus 1. And then they plugged in their 7 here and got 36. 5 times 7 is 35, plus 1 is 36. So same answer, different way to do it. Which way is better? The way that makes more sense for you, the way that works for you. What's a common error? Be sure to answer the question that is posed. Yep, I don't know if you noticed, I started thinking, oh, I'm probably just going to go find out whatever this piece is. But it actually asks me to find the whole FH. Okay. It says points J, K, and L are collinear. All right. Let's try this one out. So I think this might be where your numbers are different than mine. If we had the exact same numbers, that's great. So it tells me JL is 25. JL. Oh, that's JL is 25. Oh. I only know the whole distance. But hey, I know JK and I know KL. So I could say JK, if I use writing like they were writing, I know JK plus KL is equal to 25. And hey, I know JK is 3n, and I know KL is 5n minus 7. So I could combine like terms here. 3n plus 5n is 8n. Bring down the 7. And then we just solve this, right? Add the 7 to both sides, then divide by 8. So plus 7. 25 plus 7 is 32. So 8n is equal to 32. Then divide both sides by 8. And 32 divided by 8 is 4. So n is equal to 4. Oh, there I go again. I don't actually know what the question is. Let me see what the question is. Oh, the question says, what is n? Okay. Well, n is 4. But then it says, what is jk and what is kl? And this is where, okay, well, we know jk, we know kl by knowing what n is. If n's 4, then jk is just the 3n. So 3n is 3 times 4. And then 5n minus 7, so 5 times 4 minus 7. So 3 times 4 is 12. 5 times 4 is 20. Minus 7 is 13. So I got 12 and 13. 12 and 13. I did not mean to type that n, but that's good. I should have written jk equals 12 and kl equals 13. Cool. So example 4. I try to keep these videos brief. All right, so our next thing, we're going to talk about how protractors work. This is called a protractor, and we use this to measure angles. So in case you've never used one before, the way that you do it is you lay the bottom of the protractor. There's usually a line going with it and then a hole in the middle, and you line that up with the starting ray of your angle, and then you let the ending ray of your angle finish the angle. So like if I wanted to measure BEC, that angle, I take my finger and I trace from B, and I go B down to E up to C. So I wouldn't measure BEC like this. Normally what I do is I would take B and I'd put it on the flat part here, but since I can't move this, what I can do is figure out what it's supposed to be. So let's look at this. So where does B look like it's crossing right here? Oh, see how there's two sets of numbers? This starts at 0, goes all the way up to 180. This also starts at 0 and goes up to 180 just in the backwards direction. So what I would do is I'd start at 0. I'd say it looks like it's between 40 and 50. That middle line is 45. So I'm going to say this is probably hitting at 46 or 47. Let's just say 47. But I wonder what they're going to pick. And it said B, E, C, right? So where is C coming out C's coming out between 100 and 110. Like, I use the top number here, make sure to use the top number here. So that looks like it's 105 then. So if we started at 47 and we ended up at 105, the measure of this angle then is going to be the ending minus the beginning. So if we did 105 minus 47, it should be what, 60? No, 50, 58? So my estimation is that it's about a 58-degree angle. So let's see how they do it. Since EA, that's a ray there, lines up with 0 on the top scale, use the top scale for all the other rays in the figure. By the protractor postulate, that's just a fancy way of saying, by using protractors, how they work. Oh, they got 47 and 105. 47 was what I picked too. So I guess my estimation was correct. If you thought it was 46 or 48, it's not a big deal. So if we take them and subtract them, notice that they have the absolute value bars on there. If you subtracted it the wrong way and you got a negative angle, we're just going to call it a positive angle. So they got 58, I got 58. But notice, whenever we're looking at angles, we always read them from left to right, and we follow the points from left to right. So the way that they did this is true. It's a little bit fancy for what I think the problem needs to be, but absolutely true. So here, like if I wanted A, E, C, start at A, go to E, go to C, well, A starts at 0. This is normally the way that we do it. All I have to do is look and see where C hits. C hits at 105. So I know that AEC actually is just 105. I don't have to do any more work after that. And then angle BED, this is annoying now because BED, well, I'm not starting at the flat 0 anymore. So B was, we said 47, right? So 47, and we're going to subtract 47 from wherever angle D hits, and D hits at 130, so 130 minus 47. So let's see, 83. Cool. So that's the idea with using a protractor, and it's very similar to line segments, it's just angles instead. And you might be like, oh no, this is so scary. No, this isn't bad, don't worry. We'll talk through this. And, let's try to get a better screenshot. All right. Let's see what the question is. Also, let's make the marker a little bit smaller. All right, if XWZ equals 127, okay. XWZ, oh, so all of this is equal to 127. Okay. What is YWV? So we want YWV. We want this angle in here. All right, let's talk about some ways that we notate things. Because there's some specific ways that we notate things. And they mean really specific things. So the first thing you might notice is that this says 32 degrees, and there's another angle marker here. Since they both have one bar on it like that, these actually are said to be congruent angles. This is also 32 degrees. When we do our diagrams, like let me draw a couple angles over here. Bop, 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 bop. There, I drew like 5 angles. I could say I put a marker on here, and then let's say that this one and this one actually have the same measurement. I would put the same marker on both of those. Let's say that these two have the same measurement, but it's different than that first one. I wouldn't use the same one, I would use 2 lines. So in the same diagram, I can show, oh, so these two are the same and these two are the same. And then we got a third one that's just different, so we'll use 3 lines for that, or three curves for it. Ooh, it's a rainbow. So in this diagram, since that was 32 and that has another marker, they're both 32. And then it was asking for this one, so I'll put a double marker here to show that it's different than these two. I mean, maybe it's the same, but it's probably different. And then I can find, well, I know that if the whole thing's 127, then I could say 32 plus angle YWV plus 32 equals 127. Right? All 3 of those angles add up to the whole thing, which is 127. So, well, then I just got to say, well, 32 plus 32, that's 64. And if you want, you can, instead of writing, you know, I could say angle YWV equals X, right? And I could say 64 plus X equals 127. You're allowed to be a little bit tricky like that and do substitutions. Subtract the 64 from both sides. I got X is equal to 63. 127 minus 64 is 63. So let's see what they do. Yep, so they do what I was talking about. They write it a little bit more formally than I did. Oh, and they used M. M stands for measurement of the angle. I guess I should have done that, but you know what I mean, so we're good. I just remember earlier in the video, I was like, I'm gonna make you write things really specifically. Looks like I already forgot the difference with this one. And I'm not gonna be a stickler about that. You know, as long as your writing makes sense, that's what's important. So, and then they wrote 32 plus that plus 32. So yep, they found that. They didn't do like a substitution and just call it like little x or anything. All right, let's look at our next one. What is hoof, HF? All right, let's see. Oh, cool. I love these puzzles. It's just a little puzzle. We want to find HF. So this right here is our question mark. Let's see what we know. So just like angles, line segments have the same kind of rule. See how BC right here has a single dash? Anywhere else I see a single dash, it's the same measurement. So if this is 8 right here, then that means that this is 8 right here, and this is 8 right here. And then if I knew this triple dash, then this would be the same, but I don't. Oh, I do know this double dash here is 11. That means that this is 11. Oh, so if I want to know what HF is, I know this is 11, I know this is 8. 11 plus 8, that's how long it is. And that's 19. So they write it really formally. I tend to do these not as formally. Both are correct. Whatever you're more comfortable with is the right way to do it. Study tip, be sure to read the congruency. Oh yeah, congruency. That's like equals when we're talking about distances and lengths. Congruency marks in the diagram carefully. Important information about a figure may be shown by using angle and segment congruence markings. If the measure of angle NOP, NOP, is 31, and NOQ is 114, what is ROQ? All right, let's see. Let's see if we can't figure this one out. All right. So, let me move the side in a bit. All right, move this. Oh, hey, no. Can you not? Fine. I guess for some reason I have to show a lot on the side. All right, so NOP is 31. So this one's 31. NOQ is 114. Oh, NOQ is the whole thing. Okay. 114. What is ROQ? Barbecue. Wait, no, ROQ. Oh, okay. So in this one, we've got wait, I just saw the scroll bar down here. Ugh, not letting me use it. So in this one, we see we've got 114 is the whole thing. So we know that 31 plus these two angles. But see those congruent markings? These two are equal to the same thing. So we can say we can call this one x, we can call this one x. So 31 plus x is equal to 114. Well, instead of saying plus x, couldn't we say 2x? And say this is 31 plus 2x is equal to 114? So subtract the 31 from both sides, divide by 2, boom, you got your answer. So what is that, 83 divided by 2? Did I do that right? So I got 41 and a half. Yep, okay. Ugh. Then in this figure, suppose CD is 11.5 centimeters. DE is equal to 5.3 centimeters. And the perimeter of the figure is 73.8. What is GE? Fancy. All right, this is a great problem. All right, let's see if I can zoom in a bit here and be able to look at the whole thing. Now you're letting me look at the scroll bars. Huh, that's weird. All right, so CD is 11.5. Try doing this. I don't like how fuzzy it looks. So 11.5, it's just because I'm zoomed in so far, that's why. DE is 5.3. And the perimeter is 73.8. So I know the perimeter is the entire way around. Well, 73.8 plus, sorry, 73.8 is the entire way around. So that's this side plus this side plus this side plus this side, all of it, plus this side, all of it, plus this side. That would be the perimeter. So if we want to know we know the perimeter then has to be, wait, we don't know this triple line, do we? So we can call that x. We don't know x. We know it's x plus 8 plus 11.5 plus 5.3 plus, shoot, what's that? Oh, that's congruent with the other single line, right? 8 plus another 8 plus double line. Double line's 11, okay, plus 11 plus another 11. Yes, of course you could write this more cleanly. But then, so it's going to be x plus whatever all that is, then you can find out what x is. The thing is, the question asks us for what GE is. The question actually asks us, hey, what's GE? But look, it's got a triple line. So whatever x equals, it's the same thing. It's the same thing that GE would be. So whatever you got, you know, your numbers might be a little bit different from mine, but that's the idea. You go through, you do it, boom, you got it. So then we get to our do you understand at the end. So how are the properties of segments and angles used to determine their measures? We can add pieces up to get the whole, and we can take pieces away from the whole to get other pieces. right? That's the big idea. Then part 2, Ella wrote AB is equal to the absolute value of -1 plus 5 is equal to 4. Explain Ella's error. Well, if you remember from earlier on in the lesson, the way that we did this was we did final minus initial. So we would do 5 minus -1. Let's see what they write. Yep. So they should have done minus. Vocabulary. What does it mean for segments to be congruent? What does it mean for angles to be congruent? Right? It means that they're the same, right? That they're equal to each other, same length, same measure. Yep. Suppose is a point in the interior of angle JKL. All right, so this is makes sense in persevere. Anytime you see that word persevere, it's telling us that it's going to be a little challenging. And I'll tell you right now, looking at this, my brain goes, what? Can you like show a picture? So let's actually show this. Let's show a picture. So JKL. Here's point J, here's point K, here's point L. I picked 3 random points. I should be able to do this with any 3 random points. J, K, L. Okay, I drew my angle. It says M is a point in the interior of JKL. So interior is like somewhere in here. So I'll just put the point here. We'll call that M. If angle MKL, so I go from M to K to L, okay, is 42, and JKL is 84. Oh, I got lucky. This actually looks close to what it's supposed to be. What is JKM? Oh, it wants to know this. Well, I know that 42 and that together get 84, so can I just subtract 42 from that? Oh, it's 42. It's the same number. I meant to write 42. All right. So that last one was pretty tricky, but that's how I would figure it out. I hope this lesson's been helpful, and feel free to try the homework, or try the exit ticket, see how you do, and then try the homework. So, bye.